Hello everyone, welcome to Primus Civil Services Academy. Myself Neeraj Nachiketa, Faculty of Science and Technology. I am teaching this subject for a long time to many coaching institutes in Delhi and Pan India. So you all know that mains exam GS3 paper, Science and Technology, there are 5 questions are there. As you all know that there are 2 types of questions. Either 150 words, that's a 10 marker, and 250 words, 15 markers. So what I'm going to do in this particular session, I'm going to discuss approach to write mains answer in SNT, which was asked 2024 main examination. So let us go through it one by one. As you all know that science and technology is a very dynamic area, because here you get questions from theoretical part. At the same time, you have an applied nature. And you all know that current affairs become a very integral part of SNT. So let us go to the questions one by one. Very first question was asked on fusion power. You know that for the past 5-6 years, it is all making headlines that tokamak reactor, even it was in the headline about artificial sun built by China, where it created record high temperature mimicking sun or any star, right? So all those headlines cumulatively came to the question paper of this year exam. One more thing was in the news, Prime Minister Mr. Narendra Modi, he visited France, where he attended AI summit. And he also went to a very important site in southern France called as a Cadrech, where a very important project where India is a member country called ITER, ITER, International Thermonuclear Experimental Reactor. So it was very obvious that main exam question would be asked on ITER, International Thermonuclear Experimental Reactor. So let us go through the question here. The fusion energy program in India has steadily evolved over the past few decades. Mention India's contribution. What is the first part? India's contributions to International Fusion Energy Project. That is the name of the project, ITER, International Thermonuclear Experimental Reactor. So that contributions of India, that has to be written there. Second part, what will be the implications of this success of this project for the future of global energy? That's second part. So this question has to be written in 150 words, 10 marks. So let us, let us understand what must be the approach to write 150 words, this answer. First, introduction. Now in introduction, you have to specify about nuclear power. As you know that today, nuclear power is based on fission, right? Using uranium-235 radioactive material, like India has a successful atomic energy program, where we have 3 stages program with the help of PHWR, FBR, and AHWR. We are now into the second stage, that is a fast breeder reactor. You all have read in your preparation time there, but you don't have to write all those in the answer. You have to start that today nuclear power program worldwide is an important source of electricity. Now, most of these things are based on what? Fission. But now there is a evolving paradigm, that is a hydrogen-based fusion power, where just like sun and star, which combine hydrogen nuclei, light nuclei to make a helium. And you all know that this type of reaction requires extremely high temperature. That's why fusion energy is sometimes called thermonuclear power or energy. So in the introduction, you have to write that today worldwide nuclear power generation is based on fission, uranium, plutonium, thorium. But there is one emerging area which is coming up, that is hydrogen-based fusion power, which can mimic the what happens in sun and the star. So there you are starting with the introduction part, and you are mentioning that future need of the energy as the demand will grow. We have to shift from uranium to thorium to hydrogen. Now one day after 200 years, 300 years, there will be no uranium, there will be no thorium, but hydrogen is abundant in the nature. So you have to bring from that perspective briefly 2 to 3 sentences about the fusion power in introduction. Now in this part, you have to again next what you have to bring that a lot of research is going on. Now give the background of this EAST, experimental advanced superconducting tokamak reactor, which was given the name artificial sun, which was developed by China. Same context, you give example of K-Star, that is South Korea, again superconducting tokamak reactor and developed high temperature in the lab. So few examples you can mention and say that this type of project is going to shape the future of nuclear power, particularly the fusion power. Now India's contribution you can talk about. We have an institute called Institute for Plasma Research. Institute for Plasma Research, that is a Gandhinagar in Gujarat, IPR. Gandhinagar in Gujarat, that comes under Department of Atomic Energy. And there, what you can mention, that for the last 3 decades, our Indian scientists have been working on tokamak. It's a very, very important keyword. When you write mains answer, you have to highlight the keywords. So we have a Aditya tokamak reactor. And recently we have upgraded this tokamak reactor, that is a Aditya U. And you can also mention that we have recently SST1, steady state superconducting tokamak 1. That means India has also such kind of a reactor, what we call tokamak reactor. To mention about that. And then comes to the ITER, International Thermonuclear Experimental Reactor in Cadarache. That is a place in south of France. Mentioned that 35 countries, right? How many countries? 35 countries are the part of the project, in which India, China, Russia, US, South Korea, Japan, European countries are member countries. So then you talk about ITER project. In your answer, body of the answer, go to the ITER project. Now in this context, tell that India's contribution, India is providing the cryostat for the cooling system, cryostat cooling system. That is the contribution given by India to this ITER project, which keep the entire reactor into a cooling, because any nuclear reactor, whether fission, fusion, will require cooling system. So India has built this very big one, because ITER is going to be the biggest tokamak reactor worldwide. So that is a contribution. Second, we are funding the project. Our scientists and engineers are working on the site, and is expected to generate commercial power by 2035, right? To mention that part. And then come to the global success of ITER. To mention that this project is going to be completed by 2035, and that will generate commercial fusion power. And then mention here benefits. Talk about benefits here. That means minimize radioactive nuclear waste, right? Will generate 10 times more heat than fission-based reactor. Again, in terms of the power generation will be much higher. It is not going to occupy large space. We don't have to worry about mining of the uranium or something of that, because it's purely based on hydrogen. And hydrogen we can get from water, right? So you have to mention about this commercial power generation using tokamak reactor, ITER, largest such project, its benefits. What benefits, right, mankind is going to have based on this particular ITER project? Minimization of radioactive nuclear waste management, generating very high level of temperature, 10 times more higher electricity generation, right? So all those benefits you can mention point wise here. And then you can say that sustainability, future, hydrogen based fusion power. So one is that another global implication, it will have a first in terms of energy security, sustainability, because here the fuel is hydrogen. So mankind can use for thousands of years. Second advantage, what? Commercial. That means in terms of business, economy. When such a reactor technology will be developed, so we will have the same technology in our country, in India, will have nuclear park with such kind of tokamak reactor and will generate electricity, which will solve energy crisis in our own country. Even it will make a market of the new technology in the future. That is they'll create a global market. Meet the energy security requirement at the global scale and also in India. Right? So that as a part of structure you can mention that. And finally you have to conclude the answer. So see, since it is 150 words, you cannot write paragraphs. You have to start with the paragraph, then pointers, and then finally conclude here. Now when you talk about conclusion, so what do you write in conclusion? India's participation in such kind of project will help in transfer of technology, and we will build the same reactor in future in our country, and we'll use hydrogen to generate power, right? So you can also write here that India's, that what is something called way forward. India's energy security will be met by this kind of a project in future. Way forward, very briefly. You don't have to write everything there. So very briefly mention that it is going to have the technology transfer to the country. Our scientists will build such kind of tokamak reactor and we'll use hydrogen. And we already have a green hydrogen mission to support the production of hydrogen. And we will go for fusion power in our own country. And with that, you can end the answer. So this is the one approach which I am discussing right now for this particular question there. Now moving on to the next question. Again, energy independence, 150 words. How can India achieve energy independence through clean technology? So here two words are there. Energy independence, clean technology by 2047. When India will celebrate 100 years of independence, how we can bring that one? Now, what is very important, how can biotechnology play a critical role, crucial role in this endeavor? So that means first is energy independence of India by 2047 in terms of clean energy. And second part of the question, how biotechnology can help meeting this energy need, clean energy need. So in introduction, when you write here, you have to write that, bring about this, India's growing need, demand of electricity and energy with the rising population, right? With the increase in population, with the increasing population, urbanization, right? Population, urbanization, and now since we are going to become in coming future, a global economic power. What is said here? We have already $3 trillion dollars economy, increasing GDP, gross domestic product. So that is the industrialization, economic growth. So there in that context, India will require more and more energy. That's the way you can start with the introduction. And then in the same introduction, talk about that cleaner technology pathway. Why? Paris Agreement. Climate change, Paris Agreement, COP21, 2015, and now Paris Agreement has been implemented. India's NDC, what is called nationally determined contribution, and India's commitment to fight climate change, right? Paris Agreement under UNFCCC, United Nations Framework Convention on Climate Change. So we have to move from fossil fuel based energy to non-fossil fuel energy. And here you can write here that India needs transition from fossil fuel based energy to non-fossil fuel. And we have already under national determined contribution under Paris Agreement that by 2030, India will generate 500 gigawatt clean energy. Renewable energy, like the solar, wind, and all this one. And we are also scaling up nuclear power generation. So here the question is talking about 2047, 100 years of India's independence. So now, what do we have to write? That we have to again slowly transit not only into the field of renewable power, nuclear power, but we have to also look for the development of technology which can minimize carbon emission. Right? Minimization of carbon emission or decreasing the carbon emission of the country. All these kind of key points you have to mention in the answer. And then comes here role of biotechnology. So now when you come to role of biotechnology, scientific technology, body of the answer. So you know the biotechnology is the very, very important technology of 21st century. And biotechnology can be in many areas: agriculture, medical science, industry, environment, right? Many areas can come, right? So in that context, mention about the role of biotechnology, that India's biotechnology sector is growing very fast, right? And we have already 3 missions. We have a Department of Biotechnology has got a Bio 3E mission, right? PIB, Press Information Bureau. So what is Bio 3E mission? 3E stands for, triple E stands for, one is economy, second is energy, and third is environment, right? Economy, energy, environment. That is what the government of India has given thrust. And we have been now promoting such cleaner technology, which can be supported by biotechnology. So that part you have to mention. And now you write about some key biotech technology. So now you all know that I'll bring about a very, very important thing here, which you are aware of it. First is what? Biofuel. What is the area? Biofuel. So here, biofuel, like you know the bioethanol, ethanol blended petrol, and biodiesel. Now you know that biofermentation, organic matter, particularly the waste material, right? The waste material which can be biodegraded by microorganism under anaerobic condition in a bioreactor to produce ethanol, which we can blend with the petrol. And we already have a national biofuel mission, EBP and biodiesel, biorefinery, biodiesel, and government of India already have a biofuel mission here, right? We have a national biofuel mission. Now what the national biofuel mission aims at? That we should aim at target of 20% blending of ethanol with the petrol, right? By 2030. Then funding for biorefineries, for biodiesel, and we are promoting basic biofuel and advanced biofuel, 2G and 3G. 3G is based on microfuel, microalgae based generation of ethanol. 2G is based on the normal fermentation technology. So there biofuel can be. Second, what comes here? WTE, waste to energy. See, we are generating a lot of garbage, solid waste. And you know the solid waste can be both biodegradable, non-biodegradable. Like when we say domestic, municipal solid waste. So there are food items which we throw out in dustbin. Agricultural waste, like you know, rice husk or stubble or something, which simply we burn it, which pollute the air. Simply we can take those kind of agriculture waste material, which are organic in nature, and we can ferment it, convert waste to energy. Or when we burn it in a system, WTE plant, which will produce electricity. Again, that is a biotechnology intervention to that, right? Then again, biotechnology can also help, right, in the energy part, that is what we call biogas, right? You know that gobar gas, cow dung. So even you know that manure and the biogas, and already there is a program called Govardhan mission, Govardhan, right? Already central government is implementing with the help of state government. Biogas, you know that we already been running for long time. Methane, biomethanation. And the same methane can be converted into CNG, compressed natural gas, not only for cooking but also for vehicular use. And now you know hydrogen mixed with CNG, we are using in the vehicles there. So if you can bring in your body of the answer these three areas of biotech in terms of clean energy with the government programs and policies, you will get marks. And then you can integration strategy. We can integrate this one with what? Agriculture, industry, industrial generation of clean energy by using this type of technology, biotechnology based kind of generation of electricity. Agriculture support, where agriculture waste can be converted into the electricity or energy part, right? Domestic and municipal level, urban areas, there again biotechnology can play a very pivotal role. So we have to integrate the sectors. And you know that now we are promoting circular economy. So here you can mention the term circular economy, where we are reducing the waste material. Reduce, reuse, recycle. And biotechnology can play a very important role. And then here conclusion, way forward. What you will write way forward? That today such technology exists in India, and with the budget, union budget and state budget, this technology need to go to the grassroots level. How would you conclude the answer? Today such kind of a clean technology with the help of biotechnology exists, and today with the union budget and the state budget, such technology can be implemented at the grassroots level, and this can bring a very important bioeconomy, what will be something called as India becoming a bioeconomic hub. So with this, you can end 2-3 sentences, you can end your answer, right? So this is one can easily write. Again, challenge is what? 150 words. Specific points, to the points, good points, marks. If you can bring all these things in 150 words, you are the winner. And this is not very easy. It can only come with practice, means answer writing practice. So we in Primus Civil Service Academy helping to write good answer of science and technology, because it is one of the very challenging area in GS3 paper. So you know the correct approach to write within the time limit of 7 minutes to 8 minutes. And it can be written. And you know that if you can bring such kind of dimensions, nobody can stop you to get good marks. Right? Let's go to the next question here. Next question. Very important. It all again comes in the news. So what is here? Carbon capture. What is carbon capture, utilization and storage? CCUS technology. What is the potential role of carbon capture, utilization and storage technology in terms of tackling climate change? Again, 10 marks, 150 words. So what should be your approach to answer? One is the introduction here. So what do you write in introduction? Climate change, a global issues, right, which is threatening mankind. And here you give example, heat wave, sea level rise, extreme weather events like cyclones, right, biodiversity loss, right, melting of polar ice, mountain glaciers, all which is happening because of global warming, changing rainfall pattern, right, impact on agriculture and food security. So here in the introduction paragraph, bring about in a very brief manner impact of climate change. And there in this context, mention that climate change impacts, give examples here. You don't have to explain, just give examples. That is threatening not only at the global level, but also India, right, being threatened because of climate change impacts. So here, you start your paragraph with the global warming climate change. 2-3 sentences there. And then say that in order to fight climate change, right, in order to fight climate change, we have to look for some kind of technology which can reduce carbon emission. What is very important? Reducing carbon emission. And there you write in the answer that today greenhouse gases emissions, whether carbon dioxide, methane, nitrous oxide come from various sources. You know that first source is thermal power plants, like electricity generation, industries, then vehicles, then agriculture, 4 5 main sources. So reducing carbon emission is a challenge which come from multiple sources. Today, modern life, modern age, the kind of development we have, we are generating a lot of greenhouse gases. Just briefly mention that sources like vehicles, industries, thermal power plants, they majorly contribute towards the emission of greenhouse gases. So now comes very important, what method we can do for carbon capture. What is something there, carbon capture. So what you can also write here in the part of the introduction, this Paris Agreement, which I've just explained, that UNFCCC, United Nations Framework Convention on Climate Change, and you can write there net zero. Governments worldwide has committed net zero by 2050. What do you mean by net zero? Whatever amount of emission need to be captured by absorption. And there you also mentioned India has committed 2070. See, global net zero will be under Paris Agreement 2015. But India has asked for 2070. To mention that requirement, goals, targets under Paris Agreement that require the governments to go for net zero. So we have to look for some mechanism by which we can reduce the carbon emissions. And there are many methods are there, natural and artificial. So now you talk about the emerging technology. The body of the answer, you now come to CCUS, carbon capture and utilization and storage technology is the advanced technology, emerging technology. This is a very advanced technology which is now being developed to capture the greenhouse gases. And now you explain the mechanism, working mechanism. Now, when you draw the working mechanism, you can also draw a diagram here. You can draw diagram or flow chart to explain it. Now, how we can draw the here? Tell that let's say thermal power plant. Let me explain here. Thermal power plant where the chimney, smokestack, where the carbon dioxide and all these gases are coming out of in the air. So what is the method here? We can take them through a pipeline. Let's say you have a factory, thermal power plant, whatever the source, TPP. So this can be taken by a pipeline. Even you can draw a flow chart there. Instead of letting it go to the air, so what the technology of CCUS is there? We can capture it in the factory or thermal power plant or whatever sources are there. And then through pipeline, we can take to a particular place where we can underground, which is called underground. We can create a reservoir. We have a reservoir here. Now what reservoir could be there? It can be impermeable rocks under the earth. What could be reservoir? It can be depleted oil and gas reservoir. We have a mining there. Once we have taken out the oil and the gas, it's a natural gas, depleted area. But depletion of oil and gas is there. There we can bury it, we can pump it there. Even coal mine or any mining site, underground mines, once the mining is over, again this pipeline can take this and store it in this kind of reservoir, underground reservoir, right? And then what we can do, we are storing there. We are not letting it go to the air because if it goes to the air, greenhouse effect, global warming and climate change impacts. So we are storing it here. And then what we do, we chemically transform it. Chemically transformed into some kind of fuel or some kind of other kind of material, right? Or another kind of a material could be there, right? That could be the part of here, right? So that is where one needs to know how the things can go into that one, right? There, what we have to be aware of that. This is where the technology can work there, right? Where the technology can work into that area there. That means chemically we can transform it. Transformation. Right? Chemically we can transform. And we can use it for some other application. Some kind of chemical, some kind of a fuel can be converted through such kind of, and it's a very high tech. It's not easy, very high tech. So in one paragraph, you can explain the mechanism briefly. If you want to draw the diagram, you can draw the diagram. Flowchart also there. Then what comes here? Global and Indian potential. You can say that if you look at the benefits, that one is that with this kind of advanced technology, we are helping air or atmosphere getting the gases there. So here the benefit is that so it can minimize, that is here, carbon emissions, which will go down, reduction, and it will protect our planet, global planet protection from climate change impact like sea level rise, extreme weather event, protection from climate change. When the greenhouse gases will be captured and utilized in some form, so that means the rising temperature will be able to mitigate it. What is something called mitigation? We will be able to mitigate, and again, whatever will transform chemically can be utilized here. Maybe further industrial utilization. What could be here? Further application somewhere in industries, and we can earn money from there, right? And in India potential, you can write that we have so many power generation, so we don't have to worry about. See, first thing is that we don't have to worry about the pollution. Again here, minimizing the pollution also there. Not only global warming we are talking about, but we are also talking about pollution part also there. And health impact. It will help protect the health. So at the local level or India level, you say that if you are able to capture such kind of carbon going to the atmosphere, carbon dioxide and other gases, so air pollution, the other kind of pollution which is caused, even meeting our Paris Agreement targets of NDC, natural determined contribution, protecting the people from the health impact, and some kind of utilization which we can do it for long term there. And then you can way forward. You can talk about way forward. What is way forward conclusion? That you can say, although this technology, how would you write to way forward? Although this technology is in a nascent stage, this technology is very advanced and is in the nascent stage of development. How would you conclude the answer? Although this technology is very, very useful, but it is now in a nascent stage. And in the nascent stage, now it requires a lot of expenditure, lot of finance, a lot of fund to develop such kind of technology. At the same time, it also requires manpower to deal with such kind of high-tech CCUS technology here. Carbon capture, utilization storage technology requires those kind of skilled scientists, engineers, geoscientists and all these engineers, environmental engineers to work into this area, and require very high input cost, expenditure. So those limitation parts are there, but you can say that nascent stage, advanced technology, but India can leverage it, right? But there is a potential for our country to do R&D, research and development, and leverage such technology. That part you can mention in the answer there. So, but again, I have given you detailed part of discussion, but you know that 150 words. Use some kind of flow chart, diagram, something you can mention that, right? So that will be required here. So now moving on to the next. Question number 4, nanotechnology. See, nanotechnology has become so important for both prelims and the mains exam that regularly the questions are asked in the exam. If you go to the past 10 years question paper, UPSC has asked nanotechnology question at least 3 times in the main exam, even the prelims exam also. Let's look at the question. How does nanotechnology offer significant advancements in the field of agriculture? Specific to agriculture. Then comes, how can this technology help to uplift the socio-economic status of farmers, social economic status of farmers. So agriculture based. But now see, it's a 250 words question, 15 markers. You can write a lot of things there. So if you look at approach to the answer, introduction. So first you write about nanotechnology. When you start the answer, you will write about nanotechnology. So you have to say that nanotechnology is the key technology of 21st century, and it uses nanoparticles, nanomaterials, which has a wide application in the field of agriculture, industry, environment, medical science, electronics and communication technology, computer science, space technology, defense, nuclear, etc. So start with that. Nanotechnology is the key technology, is a key tech of 21st century. This is how you can start your introduction. And right here, that nanomaterials, nanoparticles of nano size, you know that 10 to the power minus 9 meters, 1 to 100 nanometer size. And then you mention that has a wide applications and give examples there that we can use in medical science, like, nano gold particles for treatment of cancer, nano sensor, nanomaterials can be used in prosthetic. You can talk about chip, nano chip, electronics, nano sensor, right? You can also mention about very, very important here in terms of nano filter, right? Composite materials. Give examples here. This will be your introduction, right? And then you can draw a flowchart. After this, you can draw a flowchart where you can mention different domains of nanotechnology application in a flowchart, right? Then what you can write? Now you can come to the body of the answer. Application agriculture. Now the body of the answer, you write that nanotechnology can revolutionize field of agriculture, and the future farming system will have the use of such nanotechnology in terms of growing high yield crops, managing the waste material, and also saving the environment. This is where you can start your paragraph, right? And then you write here that nanotech in agriculture, what 3 words I have said here? Yield, increasing the yield. Again, what I said here? Saving environment. Although, nanotechnology has a negative impact also there, but it can protect from some other harmful environmental impacts. Like, for example, it can clean the soil or water. Then again, not only yield and saving environment, but also it can provide the other benefits also, like in terms of providing the inputs, such as technological input, nanotechnology input, in terms of better management of crops. So better management of crops. Some generic points, right? And then come to this one. Now, in the body of the answer, your next thing will be what type of examples you can give. So you can write here, like, that nano urea. One of the very good example is nano urea, nano DAP, dissolved form of the urea. And the government of India, central government, IFCO, there's a company which is now manufacturing nano urea in having nano form. Now, what are the benefits of this? You have to mention benefit also there. What are benefits? It can be easily assimilated by roots. It will not require too much of urea, nitrogenous fertilizer, which farmer today use, chemical fertilizer, synthetic fertilizer. It pollutes the water, it pollutes the soil, and then again, subsidy. As the government provides the subsidy for that, too much of urea is going to affect. And again, biomagnification in the food chain, health impact, which we eat the food and all. So there you can write here, this nano urea is more efficient in terms of absorption by plants, less consumption, saving the money of the farmer. So if you look at here, you're giving nano, so what you can do, you can club this one, benefit for the farmer, and the application together. Let's say point number 1, nano urea. And now you write the benefit of nano urea. So what is benefit? Less consumption. So that money will be saved. The government, exchequer money, which gives the subsidy, government subsidy in the fertilizer, that can be minimized. Then again, better efficiency, better absorption efficiency. It can provide more yield of the crop, higher yield, right? Higher yield. Now this is the first application you have written. Now come to second application, nano silver. Give 2-3 applications, that will give you more better marks. And it's a 250 words answer. Nano silver. Scientists have developed. What is the advantage on what nano silver can do? That it kill the germicidal. It kills the germs, harmful bacteria, germicidal. Harmful bacteria. Like today we use chemical pesticide and herbicides, weedicides. So we can use nano silver. Although it may have negative impact, that silver going to the food chain by manipulation, but we can minimize the use of such kind of chemical kind of forms of pesticide, insecticide in terms of nano, we write nano germicidal, pesticidal, right? So that again the benefit. Then write third example of nanotechnology agriculture, nano sensor, which can record. You can also write nano sensor, like we can record temperature, like parameters, agriculture parameters, water level, humidity level, right? Water, right? How much is the moisture in the soil health condition. And we can get the information like record parameters, soil health. Farmer will get all the input through such kind of sensor. And tomorrow, in coming time, we will be able to do the precision farming. What is something called precision farming? Where the technology, such kind of nanotechnology, will play a very critical role in that precision farming. And such sensor can also be part of IoT, Internet of Things. Right? Again, you can give the benefit here. We'll get all the data about this one and can be integrated with the Internet of Things, where automation in the farm sector with such kind of nano sensor will work, embedded sensors. Again, you can give the example here. Then what comes here? Now what comes here is a very, very important thing here, socio-economic impact. That is a social economic impacts. So first you can write benefits. See here 250 words, you can bring negative side also. But first you write with benefits. That is a minimum cost, minimize the excess use of fertilizer. So that will save the money. See what I'm saying? Minimize the excess use of fertilizer when we use nano fertilizer. So that money will be saved. Then again, better yield, protection of environment, that will not use such kind of a high level of urea, so that protection of environment can be there. And again, human health, too much of urea which in the food chain, it affects our human body. And then social economic impact, that is one thing is there. Again, you bring that negative part also there. With 250 words, you can write some demerits. That recent time in the newspaper has come that nano urea can have other impact there. Like for example, it says that it can be again not been able to completely get assimilated in the plant, or may have some other impact on other living organism there. Like sometimes we talk about biodiversity loss, right? Even that can be caused. Yield, what we say, substantial yield compared to normal fertilizer, urea, how much yield we get? Whatever we are putting the input and the outcome. So we have to again make a cross comparison there. Then when you say nano silver, silver when it goes to human body, nano silver across the food chain, what impact on human body will be there? So some kind of demerit, right? Soil impact, health impact, impact on other living organisms. So that you can mention briefly here. Yes, it has a positive impact, but there will be some kind of negative impacts also there. And then you can conclude here, conclusion that nanotechnology as technology is transforming every sector of and also playing a critical role in human lives. So we cannot say no to nanotechnology. So nanotechnology in agriculture has benefits, has a demerit. So we have to regulate it, control the negative, and then harness the benefits. That will be your conclusion. And in this context, we talk about the government, budget, the financial support. That could be the part of the conclusion, right? Now let's go to the last question here. Semiconductor. Obvious, right? It was obvious that, and you know that Trump tariff war, right? So what you can do in this question here? So first, let me read the question. India aims to become a semiconductor manufacturing hub. Hardware manufacturing, chip, right? Nano chip, microchip. What are the challenges? Now here, question about challenges faced by the semiconductor industry in India. Then it says mention the salient features of the Indian Semiconductor Mission, ISM. Now what should be your 15 marks, 250 words you can write easily the long answer. Now approach to the answer here. See, when you come to introduction, so how would you write that? You can start your introduction like that India is a strong player in IT, ES, information technology enabled services. That is a software, information technology. But lack ESDM. ESDM. So what is ESDM? Electronic System Design and Manufacturing segment. Electronic System Design and Manufacturing segment. We are very strong in service industry. No, software engineer, computer scientists, computer engineers, we are very strong in that. But where we lack electronic system design, manufacturing or hardware. And every electronic system, and today you know that whatever system we use, they have chip. So now you write, when you talk about chips, semiconductor, IC, what is called as a integrated circuit. IC is is called to be very important. That is a diamond. Is a, you can say, as we say, oil, crude oil. It is a electronic gold. Is a electronic gold or diamond for any kind of product. Whatever you talk about, camera, TV, AC, everywhere, mobile phone, laptop, computers, all require chips. So you have to start with the answer like this. And then in the introduction, what you can mention? That recent time, America, Donald Trump tariff and this US policy. What is now is happening there? China, US-China war. America, the President Donald Trump is taxing the American companies who are having the manufacturing of such kind of chips in China, and saying that those kind of manufacturing should be done in USA. That means US government don't want this kind of chip technology and the manufacturing in the developing country. Not only China, but also in India, against India also. So we cannot depend ourselves on China, Japan, South Korea, Taiwan, and even US or European country for this kind of a chip, which is required in many kind of systems and products. So we are dependent. Trump tariff, USA policy, and then again this USA, China, the change in geopolitical scenario there. There is something called chip war. And you can give one very good example here. Recently, American government, NVIDIA. NVIDIA is a very, very important company, right, known for chip manufacturing. Intel and all this one, NVIDIA. So Trump government put a very high amount of tax on NVIDIA for their manufacturing in China. Even US government is putting pressure on other American giant tech companies to have the manufacturing in the US, not to transfer any such kind of thing to other countries. So for India, now the scenario to go for manufacturing. So what is, you are given a context, why there is a problem, what is the aspect here. Then come to the challenge here. Now when you write about body of the answer, challenges, you give the, wherever the products are used, challenges. What is first challenges? You can write here, there are many challenges for the country. You write from India, but again give in the initial part of your answer, write about this one, Vikram. We have made a Vikram chip, IIT Madras and all this one. We are now trying to develop those kind of chips there. So what you can give some examples also, where it is something called Make in India, Atmanirbhar Bharat. Atmanirbhar Bharat. So now challenges you can write here. Now what are challenges there first? First is that the components, hardware components. See, IC layout, you have so many components, transistor, register, all those kind of, we fabricate. Second is that components availability. It requires a high-tech, second is high-tech, we require high-tech lab and unit. It's not that software industry, take 10 computer, 10 engineer company starts. Here you have to do the fabrication on the chip. It requires very, very high-tech level of instrumentation. So what is required? High budget, high cost. What is required here? High cost. What is fourth thing? Challenge. If you ask anybody what you want to become as an engineer, I will become computer scientist or computer engineer. See, the Indian society has a mentality. Everybody want to become computer engineer and then on the street, 10,000 job, 10,000 rupees salary, 20,000 salary. You know that. If you ask a parent or a child to go for ECE, electronics communication engineering, very few people will take because it is a more difficult area. And people think the job market. But I'll tell you that future job market will be electronics and semiconductors. Bangalore already is now going for two very big things. One is a aviation sector and second is a semiconductor. Indian government is giving a lot of input to this semiconductor industry. And there will be huge potential for jobs for engineers coming from electronics and this kind of background. But again, what is the problem here? Manpower crunch, skilled manpower. Even today, those who study electronics engineering, they're good in books, theory part, but lacks the skill, capacity development, building there. That becomes a problem there. Again, what is here? Technology transfer at the global level, because these are high technology and because of geopolitical scenario, there may be restriction. The components of the chip and the important technology to fabricate the chip, those technology transfer coming to India, import, there can be restriction by advanced countries. They will restrict, put tax on that. And again, IPR issues will also come. Intellectual property rights issues. Because many such technologies are IPR protected. And there is one area of intellectual property rights that is called semiconductor design rights. Semiconductor IC design right may be protected under that IPR. So these are the challenges. Then you write about Indian semiconductor mission and its provisions, important provisions. What are provisions here? So you write here, and that is given in the PIB, Press Information Bureau. You'll find the mention that's kind of government program there. You write here, first is what? India to become a industry leader. So in terms of what is called Atmanirbhar Bharat Make in India program. Now, what government is doing under this program? There will be hub, semiconductor manufacturing hub, startups, right? To promote startups, startup ecosystems. So government will be giving those kind of like semiconductor parks, just like we have IT parks. Semiconductor parks will be set up. Like Bangalore, I have given example. Hyderabad, Chennai, right? Those kind of parks will be set up. Well, the government is giving the fund to bring those kind of things, startups. Then what is here? R&D, research and development, right? Like I have given that IIT Madras, right? ISC Bangalore, IIT Bombay, IIT Kanpur, NITs, many such institutions. They will be going for such kind of a research and development to develop. Then what comes here? Here, IP protection. Then again, you know, translation, like TTO, Technology Transfer Organization, which will make the lab to the market, will help to bring this kind of R&D and new type of chip from lab to the market. So this organization will be working there. Now, startup ecosystem, that is a government is going to support such kind of startups and build a startup ecosystem, bring those economic aspects. So all those provisions you can write. That is a salient feature. What are salient features are there, right? And recently it is done there. And then finally, you can conclude your answer. So what you will write in the conclusion? In the conclusion, you will be writing about those type of input, like for example, way forward. That we cannot, you give example that recently we have been developing some kind of chips, but they are not that level of advanced level what American companies and other Chinese, Japanese, you know, other countries have got. So what is required here? Funding, right? Training, capacity building, policy change, you know, policy framework, implementation, creating out such kind of environment for the companies to go for chip manufacturing in the country, right? Those kind of thing. And you can say that India has a huge potential. With a positive note, we have a huge potential that we have so many ECE engineers, right? Electronics engineers in the country, they can get the job employment, right? In terms of employment in the coming year. And we don't have to depend on other things. What is something called self-reliance? That India will become self-reliant in the manufacturing of semiconductor. So something with way forward. You can end the answer. You have writing challenges, problems, but you are bringing some positive note also. So 250 words, you can write lots of things. And it's a very, very good question asked there from current affairs based on that. So I have tried today in this session to give you a kind of understanding or approach to go for answer writing. Now GS3 paper, 5 questions, 2 15 markers, that's 30 marks. 3 10 markers, 30 marks. That means you have a 60 marks in GS3 paper on science and technology. And science and technology have got 15 to 20 questions in prelims exam, preliminary exam, PT exam, preliminary. 15 to 20 question MCQs in science and technology. You cannot neglect this subject. So all these areas, I've been teaching this subject for a long time. And so you can connect with us and we will be there to help you out in terms of this subject, and also you can join our foundation batch. So I thank all of you to participate in this session there, and looking forward to meet you. Thank you. Thanks a lot. And for anything, please contact Primus. I'll see you soon there. Thank you. Take care. Bye-bye. Thank you.